turned it in, 90% missed it. So I want to go over it because I don't take off points when you miss it. It just helps me know whether you understood it or not. So, share. Okay, here's the problem. Also, you might want to take a picture of these because I don't know if the graph will show up when you go to do today's attendance. It's this one.
It showed up. I already did it.
Oh, good. Okay. Because sometimes the graphs don't always show up on everyone's. And then this will be Friday. So if you want to take a picture of it in case something doesn't work compatible wise with your computer, iPad, phone, depending on what you use. Okay. But I only want to go over the first one. I want to wait and see what answers I get for Wednesday. I think 2 people turned in Wednesday so far. But we covered both of these. Yeah, I think we did do these also. So we've done all 3 of them. But for the first one, we want to find the limit as x approaches 7. X squared minus 5x minus 14 over x squared minus 49. Whenever you're taking the limit of a number, plug the number in and see what you get. If you get a good answer, then you're done. So we would have 7 squared minus 5 times 7 minus 14 over 7 squared minus 49. And when we do that, you get 0 over 0. When you get 0 over 0, it means there was a common factor, so you have to go back. And in this case, since they're quadratics, factor. The bottom, this is x squared and 7 squared, so the difference of squares, x minus 7 and x plus 7. The top, we need 2 numbers that when we multiply, we get a negative 14, and when we add, we get negative 5. So what 2 numbers, when we multiply, we get a negative 14, that when we add, we get a negative 5? And go ahead. Oh, go ahead.
Negative 7 and 2.
Mm-hmm. When we multiply these, we get negative 14, and when we add them, we get a negative 5. So we get x minus 7 and x plus 2. Notice the x minus 7s will cancel. That's what was giving us the 0 over 0. So then you plug 7 in again, and you should get 9/14. Any questions on that? Oh, that was given. Find the limit as x approaches 7. And then when we plugged the 7 in, we got 0 over 0, which meant there was a common factor. So we factored the top and bottom, and the common factor cancels. And then we plug 7 in again. But the limit as x approaches 7 was given. Any questions on that? We did 41. Okay. So last class we did up to 41. The next group, notice their limits 43, 44, limits to infinity. And there's 3 rules. So this is 6.1 continued. There's 3 rules when you have limits to infinity. When you have a limit to infinity, you need to look at the degree of the polynomial, and these limit to infinity ones will all be fractions. The first case is if the degree of the top polynomial is equal to the degree of the bottom or denominator. So if the degree of the top and the bottom is the same, reduce the 2 leading terms. By leading terms, it means the terms with the largest degree. And the degree is the largest exponent. So like the problem we just did, the degree on the top and the bottom is both 2, because it's our largest exponent. Let's look at number 43. So we're finding the limit as x goes to infinity of 3x over 7x minus 1. The degree is your largest exponent. Remember, when there's no number, it's a 1. So the degree of the top is 1. And the same thing here, the exponent is 1. So the degree on the bottom is also 1. When they are both the same, take the 2 leading terms, the ones with the largest exponents, and reduce them. So the limit as x goes to infinity will approach 3/7. Any questions on that one? Let's try 45. So looking at this function, what's the degree on the top? Type it into the chat. You want to look at the exponent instead. So 3 would be the leading coefficient, 2 would be the exponent. So yes, the degree would be 2. My other class didn't want to respond to things. And so for responding, I will give you 1 extra point on your test. So last class we gave 2 points. That went on to the last exam. But this time I'll give 1 point each time you answer first, or well, I'll take all of them today, but up to 4. And that will go on to your next exam, which is next week. So for today and Friday, when I ask a question, type it into the chat. Someone just typed 2. But I already took a picture. I will give you the points for it. Okay, can't keep putting it in now. But normally it will just be the first person that answers. So then the degree of the bottom is also the exponent, which is a 2. When these are both the same, then it's going to approach this largest degree term. Because when you're talking about a billion squared, 2 billion isn't much. So it will eventually, as the number gets larger, approach these 2. And therefore you can just take the 2 largest degree terms and reduce them. So it will approach 3/2. Sometimes you have to reduce the number. Now, negative or positive infinity would be the same. Oh, okay, number 44. The limit as x approaches negative infinity, 8x plus 2 over 4x minus 5. What is the limit as x approaches negative infinity? 2. Okay, the degree on the top and bottom is 1. And then those that are answering 2 are also correct, because if you take 8x over 4x, since the degree on top and bottom is the same, the x's cancel and 8/4 is 2. Any questions? So when the degree of the top and the bottom is the same, just reduce the 2 largest degree terms. The next one, and maybe even a little easier, is when the degree on the bottom is larger. When the degree on the bottom is larger, the limit is 0. Because the bottom is going to grow a lot faster. And when you take a small number divided by a large number, it approaches 0. So if we look at 48. The limit as x approaches positive infinity, 2x squared minus 1 over 3x to the fourth plus 2. What's the degree on the bottom? Yes. Now I'm getting quick answers. The degree on the bottom is 4. What's the degree on the top? Yes. One too many. I don't see the 4. So the degree on the top is 2. Notice the degree on the bottom is larger, so it's 0. That's a nice, easy one. No work. Degree on the bottom's larger, it's 0. If we look at number 47, again, degree on the bottom is 4. The degree on the top is 3. So our answer is 0. Any questions on this one? Now the next one is a little bit harder. When the degree on the top is larger, the number gets huge. It's either positive or negative infinity, which means the limit does not exist. So it's either approaching negative or positive infinity. There's no bound on it, so the limit doesn't exist. But it's going to ask for both answers. So you'd first put doesn't exist, and they'll say, well, is it approaching positive infinity or negative infinity then? We look at, I guess, 50. We're looking for, and again, remember, whether it's a positive or negative infinity, you're still using the same steps. The limit as x approaches positive infinity. This one. X to the fourth minus x cubed minus 3x over 7x squared plus 9. The degree on the top, 4. The degree on the bottom, 2. So the degree on the top is larger. So the limit does not exist. So then we need to decide if it's positive infinity or negative infinity. Well, one way is to go to Desmos and graph it. Another way you can do it, and you only want to work with the 2 largest degree terms, you can plug in, since this is positive infinity, plug in any positive number. Now, if you were going to use this whole thing, you'd need to plug in a really large number. But if you just use the largest degree term, you could plug in a positive 1. 1 to the fourth over 7 times 1 squared. And you're not even worried about the answer. You just want to know if it's positive or negative. Well, on top we have a positive. On the bottom is positive. So it is positive infinity. So as x is getting large, so is y. Positively large. If we look at x going to negative infinity, same problem. We already know it doesn't exist because the degree on the top is larger. But instead of putting a positive 1 in, this is going to negative infinity. So using the two largest degree terms, plug in a negative 1. We have a positive on top. Negative 1 squared is positive times 7 is positive. So again, this one would be positive infinity. So as x is getting negatively large, y is getting positively large. Any questions on that? To look at it graphically, I want to make sure I wrote the equation down. We can go to Desmos and plug the equation in. X to the 4th minus x cubed minus 3x. And I put parentheses so that it knows that that all goes on the top when I hit divided by. And then the denominator was 7x squared plus 9. 7x squared plus. The limit as x went to infinity, we said went to positive infinity, which makes sense. If we look at the x-axis, as x is getting large, so is y, because it's going up. And the same thing the other way. As x is getting negatively large, y is going up positively. So you can do it by looking at the graph. As I go negatively for x, y goes up, so it's positive infinity. If it went down, it would be negative infinity. Any questions on that? So those are the cases for infinity. There's 3. You will need to know the plugging in one simply because on the in-class portion, you won't use Desmos. Any questions on that? The next section is very similar. But what it does is it adds continuous to it. So if we look at number 1, it says to find all the values where the function is discontinuous. For each point of discontinuous, find f at that value, the limit from the right, from the left, and the limit at the value. I'm not too worried about what limits of continuity are not met. I didn't realize it was asking that, but I didn't go over it in my other class, so you won't be tested on. You just need to know where it's discontinuous. To know where it's discontinuous, if you trace it from left to right and never lift up your pencil, it's continuous. Anytime you have a break in the line where you would lift your pencil up, It's discontinuous at that X value. So if we look at number 1, as I'm tracing it, notice that open circle. That's where it's discontinuous. It's discontinuous at x equals -1. You want to make sure it's the x value that you're stating. So it's discontinuous at -1. So we want to find the limit as x approaches -1 from the right. The limit as x approaches -1 from the left. The limit as it approaches -1 and f of -1. The reason, well, once we find these, then you'll see why it's not continuous. In order to be continuous, these would all have the same answer. So when we find the limit as x approaches -1 from the right, that means a little bit larger. So I go where -1 is and I go to the right because that's the larger values. And notice my lines here. And as I'm getting closer and closer to that open circle, my y value is getting closer to 1/2. Any questions on that? As I'm getting closer on this side, that would be from the left. That's what this little negative means here. So we go here and just think of it negative, you take away so it's a little smaller. So it's over here. And my line comes in this way, but notice they're both coming in at the same open circle. So they're both going to have the same answer because they're both coming in together. And it is also 1/2. So when they come in together, these two are going to be equal. And if these two are equal, this one is the same. This one looks for the shaded in point. Confused on how you got that. Okay. For the 1/2, these are the y values. So when I look at -1, both lines from the right and from the left come into the same open circle. And the y value for that open circle is 1/2. So you're looking at the circle that they're both, whether it's colored in or not, the circle that they're both approaching. And in this case, they're both going in at the same one, and the y value would be 1/2. Any questions on that? This one's looking, and we're going to do another one. This one's looking in for the shaded point. Notice that at -1, there is no shaded in point. There's just an open circle. So this does not exist. So this one is discontinuous because f of -1 does not equal 1/2. Any questions on that one? Make this wider for a second. Okay, look at number 1 and 2. Notice how number 1, they're coming in together at the same spot. And that's why both answers were the same. Look at number 2. They're both coming up, but they're coming in at different spots as they come in. Because they're coming in at different spots, these are not going to be equal, which means this is not going to exist. Okay, so let's find the limits here. Now again, it's at -1. As I'm tracing, I would jump here where x is -1. So this one was also discontinuous at -1. So it's still discontinuous at -1. So we want to find the limit as x approaches -1 from the right, limit as it approaches -1 from the left, limit as x approaches -1, and f of -1. What is the limit as x approaches -1 from the right? Anyone? Go where -1 is, and then you go to the right, and notice the line above me is this one on the right side. This is on the left. So we're using this one. And as I'm approaching the point at -1, which is right here, the open circle, the y value, 1, 2, 3, 4, is 4. The -1 from the left, go to the left side. Doesn't have to. Correct. The limit, an answer for a limit is a y value, but it doesn't have to hit the y-axis. So for the left, we go to our -1 and we go a little bit to the left, the graph's over here. And as it's getting closer and closer to the point at -1, the y value is 2. So you're looking at the point at that value. Any questions on the 4 and the 2? These two are not equal, so this one does not. Then f of -1, that's your shaded in point. If we look at the point where x is -1, what's the y value? Yes, 2. So it'd be -1, 2. So this is saying when x is a -1, y is 2. Any questions on that? Or 7. Yeah, I guess we'll do 7. Now, when you have an equation rather than a graph, remember we found things were discontinuous by the domain. Whatever values are omitted from the domain, when you have a fraction, anything that gives you 0 in the denominator needs to be omitted. So we know x times x minus 2 equals 0. Anything that is a correct answer for this equation needs to be omitted. Well, when it's factored, you can set both equal to 0 and solve. And add the 2. This one's already solved. So x can not equal 0 and x cannot equal 2. Both of those give me 0 in the denominator. So it's discontinuous at x equals 0 and 2. Anything that will give me 0 in the denominator, that's where it's discontinuous. It also asks us to find the limit as it approaches that value. So if we look at the first one, the limit as x approaches 0. Well, plug it in, see what happens. Well, when we plug it in, on the top we're going to have 5. But on the bottom, 0 times a negative 2 is 0. Well, you can't take 5 divided by 0, so it does not exist. Now, other problems that we did when we had 0 in the bottom, we also had 0 in the top. Then you need to go and reduce. And we'll do one where that will happen. Limit as x approaches the other value, which is 2. Again, we plug it in. 5 plus 2 over 2 times 2 minus 2. 7 over 2 times 0 is 0. So it doesn't exist. Any questions on that one? Let's look at number 10. First thing, what value is omitted from the domain? What value can x not equal? Anyone? Okay. First, your question, it does not exist because of the 0 and the, yes, because there's a number on top and a 0 on the bottom. Now for this one, and those who put in -5 are correct, because x plus 5's the denominator, when we set it equal to 0, x cannot equal a -5. That means it's discontinuous at x equals -5. Find the limit as x approaches -5 then. And this is similar to the attendance problem that we did at the beginning, except you didn't have to find where it was discontinuous. I already gave the limit to find. So this section just takes everything you learned one step further. So x squared minus 25 over x plus 5. So we said it was discontinuous at -5. And it said find the limit wherever it's discontinuous. And you'll definitely have one like this on the exam. Plugging in the -5 squared minus 25 over -5 plus 5. This is 25 minus 25, which is 0. -5 plus 5 is 0. So the difference between these two, you have 0 over 0. That means there's a common factor and it will reduce. This one will not reduce. So if you have 0 over 0, go back and reduce it somehow. In this case, we can factor the top. This is a square. 25 is 5 squared. This is called the difference of squares. So x squared minus 5 squared is x minus 5 and x plus 5. For the -5 in the domain, whenever you have a fraction and you want to find the domain, take the denominator, set it equal to 0 and solve. So when I set the bottom equal to 0, I subtract the 5 and I get x equal to a -5. So -5 will get me 0 in the denominator, so I need to omit it. And that means it's discontinuous at that value. So anything omitted from your domain, your function is discontinuous there. You can find the limit as it approaches it, but it doesn't exist. It will have an open circle. You're welcome. Now, when we factored this, notice the 2x plus 5s. I said there was a common factor. That's what was giving us 0 on top and bottom. So then we take the limit as x approaches the -5 and plug it in again. -5 minus 5 is a -10. So a number over 0 doesn't exist, but 0 over 0, it can be simplified. Any questions on that? Well, start another sheet. Number 11 and 12, don't worry about the absolute value ones. For our course, we don't need to worry about those. But number 11, there's no fraction, there's no square roots. It's just a polynomial, and in this case, number 11 is a quadratic. It's a parabola. They're continuous. So 11 and 12 are both continuous functions. Because there's no fraction and there's no radicals, the domain is all real numbers, so they're always continuous. Um, 12 is also, it's a cubic function. With the first one, x squared is a parabola. Because the squared is positive, it's going up. And that would be your graph. So if you graphed it and traced it, it's always continuous, no breaks. The same thing with this one, it's a cubic function. Because the 3 in front is negative, it's going down. So it looks like this. Always continuous. So there's no values where it's discontinuous. Then you wouldn't go any further in this one because it always exists. Any questions on that? I think the next set of problems, they take a little longer. Is there any questions on any of that? We have a couple minutes if you need to maybe do another one. Like number 8, you would set 2x plus 1 equal to 0 and 3x plus 6 equal to 0. Actually, yeah. But they don't have the common factor in the top, so it is going to be like this one. Does not exist. Because I can see by looking at it, there's no way on top to factor it into one of those. Because if you notice here, we had a common factor. But with only a negative 2x, you can't make that factor on top. Yeah, let's do number 9 real quick, because you're definitely going to see this on next week's exam. So the first thing you want to do is find out where it's discontinuous. To do that, you find the domain. So to find the domain, we take the denominator, x minus 2, set it equal to 0, and solve. I'm going to add the 2 to the other side. So did you get 2? X cannot equal 2. Because that will give us 0 in the denominator. 2 minus 2 is 0. That means it's discontinuous at x equals 2. So let's find the limit as x approaches 2. When we plug 2 in, 2 squared minus 4 over 2 minus 2. 2 squared is 4. 4 minus 4 is 0 over 2 minus 2, which is also 0. So that means you need to go back and factor. This is the difference of squares again, x squared and 2 squared. X minus 2, x plus 2. The x minus 2's cancel. And then we plug our 2 in again. 2 plus 2 is 4. So our answer is 4. Any questions on that?